Good morning. I'm Dr. Ravina Priyadarshini, Professor of PC Department, Rohini College of Engineering and Technology. Today's class, we are going to discuss about the satellite communication. The topic is launching procedure. So, the launching procedure, how the satellite is launched. So, what are the steps involved to launch the satellites? These things will be discussed here. So, first of all, launching procedure means that if a satellite is a low altitude satellite, it can be directly launched into its or injected into its desired position. So we can say that if the altitude is of around up to 200 kilometers, the direct launching of the satellite is possible. Since it's a low altitude, we can launch the satellites directly into the corresponding orbit. But for higher altitudes, so if the altitude of the orbit is about 200 kilometers, direct launching is at somewhat a tedious process because it is not economical. It consumes a large amount of power, so power consumption as well as fuel requirement is very large. So so to launch a satellite in this higher orbit, we can go for the satellites will be made to launch in the intermediate orbits, and from the intermediate orbits the satellites will be launched. There are two intermediate orbits are there. One is the parking orbit, another one is the transfer orbit. First of all, first one is the parking orbit. So parking orbit, the launch vehicle and satellite which reaches a convenient altitude to orbit the Earth. So now they are said to be in a parking orbit. Parking orbit is nothing but a low Earth orbit, which is nearly a circular orbit and whose altitude is between 150 to 300 kilometers. Next is the transfer orbit. So the transfer orbit is named as Hermann transfer orbit. So the once the satellite is launched in the parking orbit, so the satellite is made to revolve in that particular orbit one or two times, and after that it is transferred to this transfer orbit. So the launch vehicle which will insert the satellite into this transfer orbit. Such orbit is named as Hermann transfer orbit. So in case of geostationary satellite launch, this transfer orbit is also called as geostationary transfer orbit. This orbit is selected to minimize the energy required for transfer, but the time required for these orbits will be somewhat larger when compared with the other orbits. So this is the structure of the orbits. First of all, from the Earth, the satellite is launched. So the first circle which indicates the low Earth orbit. So this is a polar orbit, or this lower orbit, it is almost a circular orbit. And next, first the satellite is injected in this orbit, and here will be the parking orbit. And from that orbit, the satellite is transferred to the Hofmann transfer orbit or the geostationary transfer orbit. So this is a elliptical orbit. So this orbit will be a highly elliptical orbit. So it takes a long time to revolve in this orbit, and once it reaches its maximum perigee as well as apogee distance, it will take the perigee kick motor as well as the apogee kick motor is enabled, and from that particular position the satellite will be launched to its or injected to its corresponding desired orbit. So that is the higher orbit. So these are the orbital transfers, how the orbital transfers are takes place. So first of all, from the Earth, the satellite is launched and the first takes the circular orbit. So the orbit is indicated in a green color, and once it reaches its maximum position from which the transfer satellite is transferred to the Human transfer orbit, so that will be elliptical path, and once it reaches the maximum perigee as well as apogee height, then the satellite will be launched to its the desired orbit. So here the transfer orbit is selected to minimize the energy required for transfer, and the orbit forms a tangent to the low altitude orbit at the point of its perigee, and the tangent to the high altitude of at the point of its apogee. At perigee, in case of rocket launch, the rocket injects the satellites into the transfer orbit with the required thrust. So in case of reusable launch vehicle, the satellite must carry a perigee kick motor which gives the required thrust. Next, at apogee, the apogee kick motor will be enabled. So it makes the change of velocity of the satellite to place in its circular orbit. So it takes 1 or 2 months for the satellite to be fully operational. So throughout the launch and acquisition phase, a network of ground station is necessary to perform the tracking, telemetry as well as command functions. Velocity changes in the same plane will change the geometry of the orbit, and also the inclination of the orbit also changed without affecting the other orbital parameters. So if the launch site is far away from the equator, it will lead to more expensive and less useful operation. And using the prograde orbits, that means that direct orbits, the launch a larger payload can be launched in the easterly direction than it's possible with the retrograde launch. Thank you.